righty, 6.3a, we are starting a new section 3. Okay, a little bit different topic, building on what we've learned in the previous section. So vertical angles by definition. Two lines that intersect from vertical angles. Vertical angles are pairs of angles that are always opposite one another rather than adjacent to each other and do not share a common ray. Okay, so looking up at this picture up here, let's pull an example out of here. So angle AJF, where's AJF and IJB. That's an example. Let me scooch that up. That's an example, one example. There are a bunch in that picture. That's an example of vertical angles. Okay. All right, adjacent angles. Let me switch colors on this one. It says two angles are adjacent if they have a common ray, side, and vertex. Okay, so let's look at angle CHI, angle CHI, and angle CHD. So they share a common ray and a vertex. Okay. All right, so you need to understand what vertical angles are and what adjacent angles are. Okay, number one, name at least two vertical angle pairs using a different colored pencil to mark each pair in the diagram above. All right, so I've kind of got my diagram already looking pretty colorful. So I'm going to just go ahead and point them out to you. So angle JIH and angle BIC. Let me show you what those are. JIH, so that guy right there, and then BIC, that angle right there. Those are vertical each other, just as these were vertical. Okay, here's another one. It says at least two. Okay, so angle EGD and angle FGH. I'll move it up in a second. EGD and angle FGH. Let's look at those two. EGD. EGD is this guy right here, and FGH is this guy right here. So those two angles are vertical. Okay, let me get another color going. Grab another color. I can use a pencil on this one. Name at least two adjacent. So here are a couple. Angle JBI and angle IBC. JBI right here, and IBC right here. So these two angles are adjacent to one another. Okay, they share a side and a vertex. And then another one could be angle EFG and angle GFJ. EFG and GFJ. EFG right here. And what was the other one? GFJ. GFJ right here. These are adjacent. They're next to. Okay. All right. What seems to be the relationship between the measures of two vertical angles? Draw another pair of vertical angles below by constructing two intersecting lines and measure the two angles in the vertical pair. Does the example support your conjecture? Okay, so vertical angles have equal measures. Vertical angles have equal measures. Okay, so let's look at this. So if I label this A, B, and this line C, D, and I tell you that I come in here and I measure this and it's 45 degrees, the measure of this one is also 45 degrees. Those are vertical angles. All right, supplementary angles. Supplementary angles, two angles whose sum is 180 degrees. Okay, looking back, actually, let's just look at the shape right here. So are we good with angle EGD and DGH or DGC? Okay, angle DGE and angle DGH. Find and name at least one pair of supplementary angles that are adjacent in the diagram and one pair that are non-adjacent. Use a different color to mark each pair in the diagram. All right, so supplementary and adjacent, let's go with angle, and I'll show you in a sec, AFE and angle EFG. So AFE, and angle EFG. Those are adjacent. They're supplementary. They add to 180 and they're next to each other. Okay, now let me change colors and do, how about this one? Angle EGF and angle DHC. EGF. So EGF and DHC. Okay, this angle and this angle add to 180, but they are not adjacent. They are not next to each other. Okay. All right, for each pair of the intersecting lines below, find the three missing measures of angles formed. Justify your answer in the table. Okay, so if this angle measure is 116, this is also 116. If this is 116, this measure needs to be 64 because it would need to add to 180. So I like to just go in and label it all up. Okay, now the measure of CEB. CEB is 116. Justify it because it is vertical to angle AED. DEB is 64 degrees. Okay, because it is supplementary to angle AED. AEC is 64 degrees. Okay, now we can get that one a number of ways. We can say it's supplementary to this one also, but now that we have this one defined, we can also say it's vertical to this one. So you have a choice on this one. I'm going to pick one, supplementary to angle AED. All right, number 6. Again, I'm going to come in here. If this is 91, straight across from it is 91. Okay, these two would need to add. If that's 89, that would be 89. Okay, so CEB CEB is 89 degrees. Okay, and that's because it is supplementary to BED. I'm sorry, BED wasn't given. CEA was given. Angle CEA. Okay, DEB is 91 degrees because it's vertical, what was given. Vertical to angle CEA. So I'm just relating everything to that given CEA. I think that's the easiest way. AED, 89, is supplementary to the one that was given. Supplementary to angle CEA. CEA. Okay, one more like this. All right, straight across, vertical is 129 degrees. That would make this 51 and this 51. Okay, now let's answer some questions. FJI. FJI is 51 degrees, supplementary to GJI. HJG is 51 degrees because it is also supplementary to angle GJI. And then FJH is 129 because it's vertical. Vertical to angle GJI. All right, for this rectangle with diagonals drawn in, there is one place where you can see supplementary and vertical angles. Use a protractor to measure one of the angles and then calculate the measures of the other three angles that have a vertex at E, using facts about vertical and supplementary pairs. All right, so if I measure one of these angles, I'm getting 120 degrees right here. Okay, well, now I'm going to use the mathematical facts. Okay, this would be 120 degrees. This would be 60 degrees, and so would this. Okay. Complementary angles. Complementary angles, a pair of angles whose sum is 90. Whose sum is 90. All right, now let's do an example from above. Let me get another color going. This angle right here and this angle right here are complementary to each other. So angle ADE and angle EDC. I'm going to put from above. No sense on rewriting a picture. All right, find and name one pair of complementary adjacent and one pair of non-adjacent angles in the rectangle above. Okay, let me use my pink to find the adjacent. Angle ABE, and I'll go back to the picture in a minute, and angle EBC. ABE is here, and EBC. Okay, those pink ones are adjacent and complementary. They're next to each other. Okay, let me get a green pen going for the non-adjacent blank. Okay, the non-adjacent blank, angle EDC and angle DAE. Okay, let me show you where those are. EDC, EDC, EDC is this guy right here. And then DAE, DAE. All right, so these two angles, this one and this one, add to 90. They add to 90, but they're not sharing a ray. Okay, and keep in mind, do you guys see skinny big, skinny big, skinny big, skinny big? Any skinny with any big is complementary. Okay, but they may or may not be adjacent depending on if they're next to each other or not. Okay, all right, so that takes care of that page. Consider a right triangle what seems to be true about the two non-right angles in the triangle. Use these examples below or draw your own examples to help with your conjecture. Let me answer that. So the two non-right angles, this one and this one, this one and this one, this one and this one. Hopefully you can see that these add to 90, these add to 90, and these add to 90. Okay, right? If you've got a 90-degree angle, don't the other two have to add to 90 to make a total of 180? Okay, so the two non-right angles in a right triangle must add to 90 degrees. Okay, what is the sum of all the angles in any triangle? Always 180 degrees. Okay, let's do some of these. State the angle relationship, write an equation, solve it, and find the given angle measure. Find the given angle measure. Find the unknown angle measure, I think is what that should say. All right, so these two angles, let's think of our vocab that we just learned. They are supplementary. We know that they added together must equal 180. When we subtract 32, we end up with x equals 148. So x equals 148. Okay, now let's answer this question of the measure of angle ABC. The measure of this angle is 148 degrees. Okay, let's look at this guy, number 12. Okay, these two together add to 90. That's complementary. So x plus 74 equal 90. Subtract 74. X equals 16. Okay, so 16 goes in that blank for x, and then the measure of angle ABC, let's make sure ABC is x, so that's going to be 16 degrees. All right. The relationship here, vertical. And we learned that vertical angles, 9x, equal each other. Okay, Please be careful on that problem. It's not 9x plus 135 equal 180. I see that mistake all the time. Vertical angles you set equal to each other and solve. So we're going to divide by 9, and that comes out to a nice even 15. So x equal 15. Okay, but what's the measure of angle JGI? JGI. We have to do 9 times 15. We have to do 9 times 15, which is 135 degrees. Okay, these two angles add to be 180. That was called supplementary. 3x plus 2x sums to 180. 5x equal 180. Divide by 5, and you get 36. So x equal 36. But what's the measure of angle KLM? KLM is 3 times 36, which is 108 degrees. Number 15. Okay, these are vertical angles. Vertical angles you set equal to each other. 2x minus 8 equal 104. You do not do 2x minus 8 plus 104 equal 180. That mistake happens all the time. Please do not make that mistake. Add 8. 2x equal 112. Divide by 2. X equal 56. Okay, and then we have to tuck in the 56 to find the measure of angle RPQ. RPQ is 2x minus 8. So we're going to do 2 times 56 and take off 8. Okay, so 2 times 56 is 112. Take off 8. I'm getting 104 degrees. All right, now this one, be very careful. Temptation's there to say complementary, but complementary angles are just 2 angles that add to 90. So these are just 3 angles which add to 90. Not complementary. Complementary angles is only 2 angles that add to 90. Okay, so the equation is going to be 2x plus 3x totals 90. That would be 6x equal 90. Divide by 6, and you get 15. Okay, so 15 is your x. Now we have to look for the measure of angle WUX. WUX is 3 times 15, which is 45 degrees. All right, we've got one last jumbo problem on the last page here. In the diagram below, angle ADB is a right angle. The figure is formed by 3 intersecting lines. Fill in the measures and justifications in the tables. Okay, so again, I like to come in here and just start labeling up what I can. Straight across this 24 is 24. If I know that this and this add to this 90 degrees, I know that this is going to be 66. If this is 66, straight across from here is also 66. Okay, now I know that the 3 of these add to 180. So right now I've got 24 and 66, which is 90. So that D, ADC right here should be 90 degrees, and this is also 90 degrees. Okay, so I labeled everything up. Now I'm going to answer the questions. Okay, angle CDA. CDA is 90 because it's supplementary to ADB. Yep. Okay, let's look at ADG. ADG is 24 degrees. because it's vertical to angle EDF. GDB is 66 degrees. Okay. It is complementary to ADG. All right, BDF. BDF is 90 degrees. Okay, now that is because it's vertical to this guy, CDA. It's vertical to this guy. Vertical to angle CDA. And then one last one, EDC. EDC is 66 degrees. Okay, there are lots of ways you can say that. Okay, you can say it is vertical GDB, since we've already talked about GDB up here. Vertical to angle GDB. That might be the easiest way. Okay, you could also say that it's complementary to EDF. EDF. You could also say that this is complementary to the EDF. It's up to you. Lots of ways to justify in these problems. Okay, thanks guys.